Imagine spending $182 billion building apartment towers, and then realizing you have more empty rooms than you know what to do with. So what do? You become a landlord. That is exactly what Meta is doing right now. In July 2026, Meta shocked the tech world by announcing Meta Compute, a business that rents out its excess AI computing power to anyone willing to pay. The stock jumped 8.8% in a single day, adding $127 billion to Meta's market cap. But CoreWeave, a company that built its entire business renting GPUs, lost 14% of its value in hours. In this video, we will break down why Meta is doing this, how much money is at stake, and what it means for the future of cloud computing. Let us start with what actually happened. On July 1, 2026, Bloomberg reported that Meta was quietly building a new cloud infrastructure business called Meta Compute. The plan is simple: rent out Meta's massive fleet of NVIDIA H100 and H200 GPUs to external customers, and also offer API access to Meta's AI models including Llama and the newly released closed-source Muse Spark. The market reaction was immediate and brutal. Meta's stock surged from around $575 to over $627. That is a single-day gain of nearly $100 billion in market value. Investors finally saw a path to monetizing the hundreds of billions Meta has been pouring into AI infrastructure. But for CoreWeave, the story was very different. CoreWeave is a company that does exactly what Meta is now proposing. It rents GPUs to AI startups. CoreWeave has a $14.2 billion contract with Meta itself. Yes, you heard that right. Meta is CoreWeave's biggest customer, and Meta is about to become its biggest competitor. CoreWeave stock crashed 14%. Nebius, a Dutch data center company, fell 17%. Even NVIDIA's stock dipped. Because if the largest buyer of GPUs starts renting them out to everyone, who needs to buy new ones? Now, here is the part that makes this story truly wild. Meta has not even officially launched this service yet. The announcement alone was enough to reshape the entire cloud computing landscape. To understand why Meta is doing this, you need to understand the sheer scale of what they have built. Over the past 3 years, Meta has been on an infrastructure spending spree unlike anything the world has ever seen. In 2025, they spent $72.2 billion on capital expenditures. In 2026, that number nearly doubled to between $125 and $145 billion. By 2028, Meta expects to have spent over $600 billion cumulatively on AI infrastructure. Let me put those numbers in perspective. Meta's 2026 capital expenditure budget of $145 billion is larger than the entire GDP of 130 countries. It is more than Meta spent in 2024 and 2025 combined. It is roughly equal to the annual revenue of Amazon Web Services. Where is all this money going? Meta now operates over 30 data centers worldwide. They are building AI-optimized facilities with capacities ranging from 1 to 5 gigawatts each. One single project in rural Louisiana carries a $27 billion price tag and will use as much electricity as 4.2 million homes. But here is the problem. Meta's internal AI models, including Llama, have not generated the kind of direct revenue that Wall Street was hoping for. Meta's revenue still comes almost entirely from advertising, about 98%. The AI models improve at targeting, but that indirect return is hard to quantify. Meanwhile, Meta's free cash flow collapsed from $26 billion in the first quarter of 2025 to just $1.2 billion in the first quarter of 2026. The second quarter of 2026 is projected to show negative free cash flow. Investors were getting nervous. They were asking the same question over and over: when will all this AI spending start paying for itself? Meta Compute is the answer. This is where the strategy gets interesting. Meta is sitting on an estimated 1.3 million high-end GPUs. That is one of the largest private GPU fleets on the planet. And according to analysts, about 35% of that capacity is sitting idle at any given time. Think about that. Over 400,000 GPUs, each worth tens of thousands of dollars, consuming electricity and generating heat but not producing any revenue. That is like buying a fleet of Ferraris and leaving a third of them in the garage. By renting out those idle GPUs, Meta can turn a massive cost center into a revenue-generating asset. Bank of America Securities estimates that Meta Compute could generate between $100 and $150 billion in annual revenue by late 2027. But it is not just about selling spare capacity. There is a deeper strategic play here. Meta has been building its own custom AI silicon called the Meta Training and Inference Accelerator, or MTIA. By creating an external market for AI compute, Meta can optimize its hardware supply chain at an even larger scale, driving down unit costs for both internal and external use. This is the same playbook Amazon used. AWS started as an internal infrastructure project. Amazon built servers for its own e-commerce business, realized it had excess capacity, and started selling it to external customers. Today, AWS generates over $100 billion in annual revenue and is Amazon's primary profit driver. Meta is following the exact same playbook, but in fast forward. Meta is not the first company to discover that excess compute can be incredibly valuable. The most dramatic example happened just weeks earlier. In May 2026, SpaceX filed an IPO document that revealed something astonishing. Elon Musk's xAI had built a massive data center called Colossus One to train its Grok AI model. But here is the problem: Colossus One was a hardware Frankenstein. It mixed H100, H200, and GB200 GPUs in a way that made large-scale training only 11% efficient. xAI decided to move its training to a new facility called Colossus 2. That left Colossus 1 with hundreds of thousands of idle GPUs. So xAI did what any rational company would do. It rented them out. Anthropic signed a contract for the entire Colossus 1 data center, paying $12.5 billion per month. The contract runs until 2029, totaling over $400 billion. Then Google signed a separate deal for about 110,000 GPUs at $9.2 billion per month. Combined, these two contracts generate about $260 billion in annualized revenue for SpaceX. To put that in perspective, SpaceX's total revenue in 2025 was $18.7 billion. The cloud business is worth more than 10 times SpaceX's core rocket business. This story sent a clear signal to every company sitting on large GPU fleets: if you have spare compute, you are literally leaving billions of dollars on the table. Meta was paying attention. So how exactly will Meta sell its compute? According to insiders, Meta is pursuing a dual-track strategy. Track 1 is the simplest: rent raw GPU capacity directly to customers. This is what CoreWeave does. Companies that need H100 clusters for training or inference can rent them from Meta by the hour. Meta can likely offer lower prices than competitors because its data centers are purpose-built and its GPU procurement costs are among the lowest in the industry due to bulk purchasing power. But Track 2 is where things get strategic. Meta plans to offer an API store, similar to Amazon's Bedrock service. Customers will be able to access Meta's AI models, including the open-source Llama family and the new closed-source Mu Spark, through simple API calls, paying by the token. This is brilliant for two reasons. First, it creates a lock-in effect. Developers who build applications on top of Llama through Meta's API are unlikely to switch to competing platforms. The more developers use Meta's AI ecosystem, the harder it becomes for them to leave. Second, it allows Meta to monetize its AI models directly. Meta has always given away Llama for free as an open-source model. But running those models on Meta's optimized infrastructure gives Meta a natural advantage. The company can offer superior performance at lower cost than any third-party cloud provider running the same models. Meta is essentially building a walled garden around its open-source strategy. Give away the software for free, but charge for the infrastructure to run it. This is exactly how Red Hat built a multi-billion-dollar business around free Linux software. If Meta Compute succeeds, it will fundamentally reshape the cloud computing industry. The cloud infrastructure market is currently worth about $600 billion per year. AWS controls roughly 28%, Azure has 21%, and Google Cloud has 14%. The remaining 37% is split among hundreds of smaller players. Meta entering this market creates a genuine fourth hyperscaler. And unlike previous challengers, Meta has several structural advantages. First, Meta has a cost advantage. Its data centers are built from the ground up for AI workloads, using custom silicon and liquid cooling. Meta has been refining its data center engineering since the Open Compute project in 2011, which improved energy efficiency by 38% and reduced construction costs by 24%. Second, Meta has a distribution advantage. Meta's platforms, Facebook, Instagram, WhatsApp, reach over 3 billion monthly active users. Any AI service running on Meta's cloud can integrate with these platforms more seamlessly than a competitor's service. Third, Meta has the AI talent. The company has been aggressively hiring AI researchers and now operates one of the most advanced AI research labs in the world. The most immediate victims of Meta Compute will be the mid-market cloud providers. Companies like DigitalOcean, Linode, and OVCloud that have been positioning themselves as AI-ready hosting platforms will struggle to compete with Meta's scale and pricing. But even the big three should be worried. If Meta can offer GPU compute at 20 to 30% below AWS prices while maintaining similar performance, the pricing pressure on the entire industry will be immense. So what does all of this mean? Meta's shift from AI consumer to AI landlord represents a fundamental change in how we think about computing power. For the past decade, the cloud computing industry was dominated by companies that built infrastructure to sell. Meta is the first company that built infrastructure for itself and is now selling the excess. This has profound implications. If Meta succeeds, we may see other large tech companies follow suit. Microsoft already has Azure. Google has Google Cloud. But what about companies like ByteDance, Tencent, or even OpenAI? Any company with large GPU fleets could theoretically become a compute landlord. The AI industry is moving from a model where everyone builds their own infrastructure to a model where infrastructure is treated as a commodity to be bought and sold. This commoditization will lower the barrier to entry for AI startups, accelerate innovation, and ultimately benefit the entire ecosystem. But it also means that the era of easy money for AI infrastructure providers is ending. Companies that made their fortune simply owning GPUs and renting them out at high margins, like CoreWeave, will face existential competition. The message from Meta is clear. If you build at hyperscale, you either use every bit of that capacity or you become a landlord. And as Zuckerberg himself said, becoming a landlord is definitely on the table. This is the new reality of the AI economy. Compute is the new real estate. And Meta just became the world's largest landlord. Subscribe for more deep dives into the business of AI.